All right, so we're doing solving trig equations. So we've been doing basic ones last week, finding solutions based on the unit circle. We've done factoring, we've done identities. So today we're going to kind of put those together. Okay, so the first one we're looking at, we've got a trinomial. Okay, so we're still following those same 4 steps. 1, get it set equal to 0. 2, factor. 3, set those factors equal to 0. And then 4, use the unit circles to find the solutions. Okay. The only problem is, on this one, we have 2 sine squared x plus 3 cosine x minus 3 equals 0. Is this factorable? Not the way it stands right now, because I have 2 different trig functions there. I have sine and I have cosine, so I can't just do trinomial factoring on this one. So I have to do something beforehand. So this is a case where we've done one before where we have to change using an identity. And specifically this one, since we can't change the regular cosine, maybe there's something we can do to the sine squared. Maybe use an identity that changes sine squared into terms of cosine. And that helps us, specifically our Pythagorean identity, which says that sine squared x equals 1 minus cosine squared x. So we're going to use this identity to change our sine squared into terms of cosine. Okay? So 2, and this becomes 1 minus cosine squared x plus 3 cosine x minus 3 equals 0. Now, notice that I put the 1 minus cosine squared in parentheses. Okay? Because the first mistake my students are going to make here is if it's not in parentheses, they're not going to remember to distribute the 2 in. Okay? So when I put these parentheses here, hopefully that should remind them that you have to distribute the 2 in to both terms. So we end up with 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Add up your like terms. So we get negative 2 cosine squared x plus 3 cosine x minus 1 equals 0. Now I could factor this the way it is, but I want to do something just to help myself out because I don't like that first squared term being negative. So what I'm going to do is I'm going to multiply through by negative 1, and I'm going to do it on both sides. Okay? Remember, you can do anything you want as long as you do it to both sides of the equation. And what that does is it changes the signs on all of my terms. Okay? But it allows me to change that first term to be positive. And now it's just a really easy trinomial factoring problem. Okay? So my first term is 2 cosine squared. So I'm going to split this up as 2 cosine x, and this will be cosine x. 1, since it only has one factor that I can use, this is 1 and 1. Since this is positive here and this is negative, that means that I know both of these should be negative. So there's my factored form. So we've done step 1, we got it equal to 0. We can factor this. Now we're in step 3 where we set our factors equal to 0. So we get 2 cosine x minus 1 equal to 0 and cosine x minus 1 equal to 0. Solve for cosine x, we get 1/2 cosine x 1. Okay? So now that we've got our factors set equal to 0, we use our unit circle. So where is cosine 1/2? What angles? Well, that's at pi over 3 and 5 pi over 3. Where is cosine equal to 1? That's at 0 and 2 pi. So those are our 4 solutions. So we've done a trinomial factoring problem before. we've done one where we had to use a trig identity. Now here's one where we do trinomial factoring and we use a trig identity. So basically we put two of the problems we've done before, we've put them together. Okay? Which is also something a teacher usually does, is that we show you one kind of problem, we show you another kind of problem, and then we put those two together to make it just one more step. Okay? All right, and then I wanted to do another double angle. Okay? So here we go. Following our 4 steps. The first step is set it equal to 0, and then second step is to factor. But since I only have one x term, that tangent of 2x, I know I'm not going to be able to factor it. I can go straight to solving it, okay, and isolating it. So the first thing I'm going to do in this one is subtract 1 from both sides and get tangent 2x equals 1, okay? Now, I cannot divide by 2 because this is technically in those parentheses, okay? And I think this is where a lot of my students tend to mess this one up, where they try to divide both sides by 2 to get rid of that 2. But we have to get rid of the tangent first before we can divide by 2, okay? So basically, right now, we start finding our solutions. So we're trying to find where tangent is equal to 1. So I take this 2x, I put it here, and now I find the angles where tangent is positive 1. Well, tangent's 1 at pi over 4. Okay? Now, it's not positive 1 at all the pi over 4s, only in the first and the third quadrant. So pi over 4 and at 5 pi over 4. Like that. So now, I got to get x by itself by dividing by 2, like that. So I get x equals pi over 8 and 5 pi over 8. Now, where 5 pi over 4 was in the third quadrant, when we divided it by 2, 5 pi over 8 is in the second quadrant, which means there's possibly more solutions. And we've done this enough times to know that when we have that 2x or 3x there that we do, we're going to have more solutions. So, next thing I'm going to do is I'm going to find the coterminal angles and I'm going to add 2 pi to both of these. Now 2 pi is the same thing as 8 pi over 4. So that's what I'm going to add to both of these. So pi over 4 plus 8 pi over 4 is 9 pi over 4, and 5 pi over 4 plus 8 pi over 4 is 13 pi over 4. Now, something I noticed my students did today in one of my classes while working the practice is they tried to add 2 pi to these here, the second one. Try to do this, add 2 pi to find the coterminal with this. It doesn't work that way. You have to do it with your original solutions, not after you divide. Okay? So you can't do this here. But now, again, I'm going to take these two solutions I've just found, divide them by 2, and I get 9 pi over 8 and 13 pi over 8. And I'm close enough to 2 pi for my second solutions because 13 pi over 8 is really close to that 16 pi over 8 that would be 2 pi. So I can stop there. And these are my final 4 solutions. Okay, so just make sure that when you're doing this, you have to go back to your original ones before you divide by 2 to add the coterminal angles to those, not to the new values after you divide by 2. And the code for today, since we're getting close to summer, is P00L P4RTY. P00L P4RTY.